All right. Wait, hold on. All right. So it is currently 6 p.m., which is time for class to start. So we're almost on our last day of G5. So I hope you guys had a great time so far. But tomorrow is going to be the last day. It's going to be a review day. So basically, this is the last normal class day. Basically, that means we're just going to be learning today. Tomorrow we're going to be reviewing, and then we're going to be playing a quizzes. If any of you don't know what quizzes is and you know what Kahoot is, that's basically what it is. So you're going to be taking like a mini quiz, and you're going to see how you do compared to other people. Of course, me and my TA are also going to be participating. So well, just to see how you guys do. Don't be worried if you get any of them wrong. I know it's a fast class. G5 is like really fast. You learn a lot of things, and you probably don't remember everything. So if you want to do good tomorrow, just review some of the slides we have, maybe some of the homeworks. But it shouldn't be too stressful. It's just for fun. So no need for studying super hard. Just understand the concepts, and you should be good. There are some trick questions on there, like very, very evil questions, but as long as you pay attention to the small details, you should be fine. But from tomorrow aside, we're going to be continuing the last normal day by learning a couple new things. For instance, units of measurement. Okay, so chapter 10, I went over it in the book. It's information that's best suited to learn yourself because it's just measuring things like inches and miles. And I know the one major reason I didn't include it is because I do have a lot of Chinese students, meaning that they'll probably never ever use miles or inches or feet or any customary units, and that's basically what G5 chapter 10 is teaching. So we're not really gonna do chapter 10 because it's mostly stuff that you guys probably will never use. Some people will use customary, some people will use metric, and that's normal. So we're not gonna go over that. So we're going to continue. All right, to chapter 11, which is polygons. So what is a polygon? So it sounds like a very fancy word. If you're in my G4 class, you know that a polygon is a shape. But more specifically, a polygon is a shape with 3 or more line segments, which means if you have something that has 3 or more lines, and they meet, you have a polygon. So your polygons are your shapes like a triangle, a circle. Actually, no, not a circle, because a circle does not have lines. It's a curve. But otherwise, it should be good. Anyways, let's look at some examples of polygons. So these are the most common ones, the ones that you should probably know, which are a triangle, 3 sides, 3 angles. The prefix or the beginning, tri, just means 3. Quadrilateral, quad is 4. 4 sides, 4 angles. If you play any video games, you should know that quad usually just means 4. Pentagon, penta is 5. 5 sides, 5 angles. Hexagon, 6 sides, 6 angles. Hex, there's another word for it, but I don't think it's class friendly. But there's another word for it that you could say for 6. You could say hex, or you could say the other word. But I'm not gonna say it because it's not class appropriate, even though that it is the official term. But okay, so for instance, we have 2 things. Over on this chart, you see this very nice looking chart filled with all the polygons you should know. So you should know triangle, quadrilateral, pentagon, hexagon, and octagon. We didn't write octagon, but octagon because it's less important. But octagon you should still know because it has 8 sides, 8 angles. So any shape with 3 sides and 3 angles is called a triangle. So this is a triangle, this is a triangle, this is a triangle. Because they have 3 sides, you can count them, and 3 angles, you can count them because they intersect. And any side with 5 angles, 5 sides can be called a pentagon. So what if all the sides were equal and all the angles were equal? So you can see in these pictures, right? These sides are all different lengths. So the green triangle, these 2 sides look the same, but this bottom one looks shorter than the other 2. And same for this one. These all look different. And this one looks like these 2 are the same, but this one's longer. Well, we call shapes that have the same length as sides regular and same angles. So these are all the regular forms. So if you can see this triangle, it has these 3 sides, and they're all equal in length. If you see this quadrilateral, which is a shape with 4 sides, it's a square because squares have 4 equal sides. A pentagon, this is a regular pentagon. Hexagon, a regular hexagon. And octagon, a regular octagon. And what the takeaway here is regular polygons mean they have the sides are all equal and the angles are all equal. So the angle part is less important, but you should just know that the sides are all equal no matter what. So this side, in a pentagon, this side is equal to this side, which is equal to this side, and all of them are equal. So can you tell if a shape is regular or not? So I'm going to give you guys a couple, maybe like 3-4 minutes to try to solve these, and then we will go over it. So is the shape regular? Meaning, are the sides and angles the same? And here is some key notation you should know. In math, if you see these mini lines, like for question 1, on the sides, if they have the same amount of lines, that means they're equal. So this has 1 line, this has 1 line, this has 1 line, which means the sides are equal. And for the rectangle, the top and bottom have 1 line, but the sides have 2 lines, which means the top and bottom are equal, and the sides are equal, but they're not equal to each other. But so you guys can go ahead and try those, and we'll go over it. All right, should have been enough time for these questions. I mean, they're not too difficult, so I don't think I expect anyone to have any difficulty. but let's go over it. So is the shape regular? So for the first one, let's go through it. So we can see that the three sides, which are marked with these lines, are all equal. And then these three angles are also equal. Another notation I forgot to tell you, if the angles all have like a marking that indicates they're the same, that means they're equal. So the first one, of course, is equilateral, which means check mark, it is. There's a special name for regular triangles. It's called an equilateral. I'll type it in the chat. But equilateral, that is the mathematical term for a regular triangle. But you can call it a regular triangle as well. No one will judge you. Second one, it is not, because the top, while the angles are all the same. See, for number two has 4 right angles, which means the angles are the same. The sides are all different. The sides are not all different, but their sides are not equal. So the top and the right side, see, you can see that they're different lengths because they're have different lines. The top and bottom are equal, and the sides are equal, but they're not equal to each other. How about number 3? It is. Technically, it doesn't mark that it has equal size, but in most questions, like for really big polygons, you don't need it, because they usually just mark it with an angle like this, and usually that's enough to tell you. If you're really technical, no, because it specifically didn't say. But for our purposes, it is, because it is. All the sides are pretty much equal. All the angles are equal. Number 4. Oh, all right. Number 4 is wrong. It is not a regular triangle. My answer is wrong, but it is an irregular. These two sides are the same, but the bottom one is different. And then these two angles are the same, but the top one is different. So it is not going to be a regular triangle. My apologies. I did not correctly put the answer. I'm going to fix that after class, but we're going to move on. So types of triangles. So triangles come in all different shapes and sizes. So there are so many that mathematicians put them into different categories. And triangles are really interesting. When you get even into further math, they still have different formulas and stuff you can always use. But we can do this either using their angles or their sides. So we can categorize them either by their angles or their sides, 2 ways. So do you guys know your angles? Hopefully you guys know your angles. There are 3 types of angles: obtuse, right, and acute. And what does that mean? An obtuse is greater than 90 degrees. A right is exactly 90 degrees, and an acute is less than 90 degrees. This is one of my easiest chapters, because all you have to remember is that obtuse is always greater than a right angle. And if anyone does not know what a right angle is, a right angle is very simple. The only thing you have to remember is that it's like a sharp corner. Like if you take a piece of paper, the corner is a right angle, or a square. It's always a right angle, 90 degrees. Exactly. Just remember 90 degrees and you'll be good. And then acute, smaller than 90 degrees. Like anything else, like 89 degrees, 88 degrees, stuff like that. Basically, anything that's literally less than 90 degrees but greater than 0. You can't have a negative angle until you get to higher levels of math. So it's going to be between 0 and 90, and then obtuse is from 90 to 360. So anything that is greater than 90 but less than 360 is obtuse, and then acute from 0 to 90, because you can't have a negative angle, because that's going to be a more advanced math if you have negative angles. Okay, so there are 3 types of triangles for the 3 angles. There are, of course, acute, right, obtuse, obviously. So a right triangle, if anyone could guess, is a triangle that has 1 right angle, and only 1 right angle. Obtuse triangle has 1 obtuse angle that's always greater than 90 degrees. And acute has angles that are all less than 90. So not too difficult, right? Right triangle has a right angle. Obtuse triangle has obtuse angle. Acute angle has all acute angles. Pretty easy stuff. So very important fact, especially for math competition, if a triangle does not have this square kind of shape at the bottom, like right here, all right triangles must have that shape to be called a right triangle. Usually the 90 degrees isn't here. Like usually like the questions will not show it. So like it's erased and you'll only see this square. If you don't see the square, that means it's not right. But if you see the square, you'll know it is a right triangle, which means it's 90 degrees. If you see a question that doesn't imply it, but the correct answer like involves a right triangle, you can say that the drawing did not put a right triangle at the corner, so it's not a right triangle. So yeah, just know that for it to be a right triangle, it has to have a square shape. All right. So now sides. There are three types of triangles for the three sides: equilateral, isosceles, and scalene. So equilateral, well, there's a special word. I also put it in chat. There's a special word that is in equilateral that might give you a hint. Well, maybe equal, right? Equilateral, which means equal is equal, lateral is sides. So equilateral, it means equal sides. So the equilateral triangle has all three equal sides. Isosceles has two same sides, only two. Two sides are the same, and the third one is different. You cannot have three sides the same, or also be equilateral. So it has to have only two sides to be isosceles. And then scalene, all three sides are different. So for instance, the last triangle I'm circling with my mouse, the bottom one is different from the side, is different from the top one, as indicated by the line. See, the bottom one has only one line, the side one only has two lines, and the top one has three lines, meaning they're all different lengths. So equilateral means all three sides are the same, isosceles, two sides are the same, and scalene, no sides are the same. And those are all the triangles that you can categorize. There's no other way to categorize these triangles. So I'll give that a moment to sink in. So there are 6 total types of triangles. You can put you can draw any triangle and give it a name. Give it either equilateral, isosceles, or scalene, or obtuse, right, or acute. You can use any of the names and give any triangle, no matter what you draw, a name. All right. So parallel or not. So when we're gonna, after the triangles, we're going to move on to the quadrilaterals, meaning the four-sided shapes. So we need to learn what parallel means. So what parallel means is two lines will never meet. So for instance, we have parallel, which are these two lines, right? These two lines will go on infinitely. They'll go on forever and ever, ever and ever, but they will never ever touch. They'll always stay the same distance apart, and they'll always go on infinitely, but no matter how far you go, they'll never touch. But what's not parallel is this second line I have right here. They don't touch, that's true, but if they go on infinitely, let's say like a little bit longer to the left side, eventually they will touch, and that is not parallel. So parallel lines are defined as they have to never ever touch. And typically in math, if two lines are parallel, they're designated with arrows, like on the line themselves. So now this is the more complicated side of geometry. We learn triangles. Triangles are pretty easy. They're not too difficult. But we're gonna move on to the quadrilateral, and as you can see from this picture, is pretty complex. So just like triangles, we can put quadrilaterals into some categories. They can be categorized into 6 different categories. So one of them is parallelogram. We have rectangle, rhombus, square, trapezoids, and kites. So 6 different quadrilaterals instead of our 2 categories and 3 per category of triangles. There's 6 different quadrilaterals. So hopefully you guys are paying attention. This is going to be a lot of information. So first one, let's talk about trapezoids. Trapezoids have only one pair of parallel sides. See, if you can see, I'm not too sure if the gray is going to come out, but the top and the bottom have these arrows pointing in the same direction, meaning they are parallel. And then these two sides are definitely not parallel because they're pointing like this. And if you made it tall enough, they'll eventually touch. So that's basically for trapezoid. There's nothing too special. Parallelogram, this is where things are complicated. So 2 pairs of parallel sides and 2 pairs of equal sides. So that means there are 1, 2, and 1 and 2. That means the top and bottom are the same, and the sides are the same length because I put one line and one line on the bottom and top. and 2 lines on the sides, which means they're the same length, but they're not same to each other. And then we have 2 pairs of parallel lines. The top and bottom are parallel. These sides are also parallel. So that's what makes a parallelogram. 2 pairs of parallel sides, 2 pairs of equal sides. Doesn't mean that, but that does not mean that all the sides are parallel and all the sides are equal. It just means that we have 2 pairs of parallel sides, 2 pairs of equal sides. If my explanation is a bit too fast, all you have to do is look at the picture, and that's all you have to do to figure it out. How about a rhombus? So it's basically the same thing as a parallelogram, except all the sides are the same. So now we have 2 pairs of parallel sides. So the top and bottom will never touch. These sides will never touch, but all these sides are the same length. I put 1 line for each line. So that means all these sides have the same length. How about a rectangle? Well, it's basically like a parallelogram, except all the angles are right angles. So the top and bottom are the same, the sides are the same, but the top and the sides are different. But all the angles are the same. So it's basically like a parallelogram, except all the angles are the same. And a square. A square is a combination of everything we have. So all the angles are the same, all the sides are the same. So that means if the top and bottom are the same length and they're parallel, the sides are the same length, they're parallel, and we have 4 right angles. And then we have a kite, but I don't think I included it because it's not too important for you guys to know. A kite is, let me go back. A kite is going to have 2 equal sides, 2 pairs of equal sides, but then none of them are parallel. So it's going to look like this. Not too important for you guys right now. There are a lot of formulas for it later on, but we're doing just simple geometry for now. So that's the overview of quadrilaterals. A lot of information, I know, but we're going to go over them. So a parallelogram. A parallelogram has opposite sides that are parallel and equal in length. This is a very, very important shape. It's the fundamental quadrilateral, and many other shapes are variations because that means they have changes of this one. Okay, a rectangle is a parallelogram with all angles equal to 90 degrees. So going back to what we just said about parallelograms, everything that makes a parallelogram makes a rectangle, except the rectangle has all 90 degrees. So I struggle a lot with these definitions, but what it's really saying is a rectangle is just a parallelogram, except all the angles are 90 degrees. So that just means, I think, let me see. If you go back to this picture, we see that the quadrilateral is the biggest one, right? It's the only one that has a special name. That means we can go to a trapezoid, we can go to a parallelogram, which can go to a rectangle. So this picture is a really good idea of the branches, like how closely they're related, and if they are like definitions of each other. So going back to this, a rectangle is basically a parallelogram with all the angles equal to 90 degrees. This looks like a square, but it didn't mark it, so we can safely assume that it is all different. A rhombus. A rhombus is a parallelogram with all the sides that are the same. So you see that these 2 sides are parallel and these 2 sides are parallel, but all the sides are the same. So we can use the definition of a parallelogram again to show what a rhombus is. So a parallelogram, but all the sides are the same. And now square. A square is a very special shape. All of its angles are 90 degrees and all of its sides are the same length. So all you have to know is that a square has a combination of all the previous things that we said. 2 pairs of parallel, all sides are equal, and all sides are 90 degrees. So that is a square. Okay, and finally, a trapezoid is a quadrilateral with only 1 pair of parallel sides. Only the top and the bottom, or the sides. Only 1 pair though. If it has 0 or 2, that means it's technically not a trapezoid. Okay, and finally a kite, which I didn't go over before, but a kite, if you got ever flown a kite yourselves, is just like that's what a kite is. It just looks like a kite. Adjacent pairs of sides that are equal in length. So what that means is that the sides that are next to each other, like these 2, are equal, and the sides that are next to each other, like these 2, are also equal. Okay, so what if a quadrilateral does not fit the description of any of those I said. For instance, if you look at this red quadrilateral, it doesn't look like a square. It doesn't look like a kite. It doesn't look like anything. We just simply call it quadrilateral. You see this one, the red one, the blue one, and the black one, they have none of the qualifications of a special quadrilateral. So we just call them quadrilaterals because that's the biggest term. A quadrilateral is any shape with 4 sides, 4 angles, nothing else. Okay, so we went over a lot of 2D shapes, but now we're going to take a little break, maybe like a 5-10 minute break. Actually, I'll give you guys 10 minutes today because a mostly relaxed day. And we're going to come back and we're going to learn 3D shapes instead of 2D shapes. So we'll give you guys until 6:35 and then we'll go over the rest. So I'll see you guys until then. All right, all right. So should have been 10 minutes break. Should have been sufficient enough for you guys after that information overload. But get ready for more information overload. For now, we're going to be learning about 3D figures. 3D figures. So what you've seen so far are all 2D shapes, meaning like on a piece of paper, like flat and basically only has length and width. But what about in the real world? We're not in the real world. We're all dealing with 3D, like three-dimensional. For instance, so now you can see some examples of 3D shapes that you might see in the real world. For instance, like a cylinder, a cube. If you ever have like a Rubik's cube, some of you smart people, rectangular prism, sphere, pyramid, or a cone. These are all examples of like regular shapes. Like a sphere you might recognize is like a regular ball. A pyramid, like if you guys know history, the Great Pyramid of Giza, or maybe like a cone, like an ice cream cone. All these shapes you should maybe are familiar with, hopefully. So a prism, special thing, special word. So a prism has no curved surface and two bases. The other faces connect to the two bases. So what does that mean? It means that it has a base. For instance, a triangular prism has triangle bases. So there's one here and one at the end. A square prism has one at the beginning and one at the end. A rectangular prism has a rectangle right here and a rectangle behind. A pentagonal prism has pentagons as faces. Hexagonal and octagonal. Basically, that's what it means. Prisms just have like what's described. So triangular has triangle and so on. So basically, they're all connected by these rectangle shapes. So prisms are just remember that prisms have like a base and they're connected. How about a cylinder? Well, a cylinder has one curved surface and two circular bases. So that's like what if a prism has circular bases? So there's a circle up here, a circle down there, and it gets connected by this curved surface. So that's what a cylinder is. It's basically if like it has circles at the bases. How about a pyramid? A pyramid has one base and no curved surfaces, and they go to a single point. So a triangular pyramid, a square pyramid, a rectangular pyramid, and so on. So they just have a base that goes to a point. So a triangular pyramid has a triangle base. A square pyramid has a square base. A rectangular, and you can see the pattern. So basically, what is described here is simply a shape, that's the base, and then a pyramid. You might be very familiar with the square pyramid because that's what the Egyptians made to as funeral rituals. Square pyramids. Just go to like Egypt and you'll see those square pyramids. How about a cone? So we go back to the pyramid example, except instead of a triangular or square base, it is going to be a circular base. So the bottom, instead of a square or triangle, is going to be a circle. A cone is a pyramid with a circular base. It has one base, which is a circle, and a curved surface that goes to a single point at the top. So it's like an ice cream cone. If you ever guys had one, that's why it's called a cone, ice cream cone. So if you can remember ice cream cone, you should be able to remember what a cone is. How about a sphere? A sphere is what you might commonly call a ball. They have no base, just one curved surface. Just remember, any rubber ball or any kind of ball-shaped thing is going to be called a sphere. And finally, when we talk about 3D shapes, we always have to talk about volume. So we know how to calculate area, right? Like of a square. If any of you have advanced knowledge, area is basically how much space a 2D object takes. And in 3D, it's called volume. In most cases, volume of an object is base times width times height. So if we have a rectangular prism, we have width, length, and height, right? We just multiply these three measurements and we'll get our volume. So for example, if we want to find the volume, just follow these steps. So we want to find the base and the height. So we calculate the area of the base, which is 8 times 7. The base is a rectangle, which is going to be 8 times 7. So the bottom is going to be 56, right? 56 centimeters squared. And then we multiply by the height, which is 9, and we'll get 504. So the area of this rectangular prism is going to be 8 times 7 times 9, or 56 times 9. So the rule is just length times width times height, and that rule holds for all prisms. So just remember base, which is going to be the bottom or any side, times height. And one last thing before we end for today, volumes of weird objects. So in the real world, not everything is perfect. We're going to be having weird shapes all the time. For instance, we have this T kind of shape. We could, for our purposes, I'm going to call it a T prism because it has a base that looks like a T, and it is indeed a prism. We can't use length times width times height because it's not a prism. So how do we do it? Well, the easiest way is to split it into shapes we already know. So there's one method which is called the additive method. We can cut the object into multiple smaller objects to find volumes. Similarly to calculus, you cut it into smaller and smaller pieces to find an exact area. So in this case, I outlined it for you. See this red line? It's going to split the T shape into two rectangular prisms. So now there's one on the bottom and one that's sticking up instead of a T shape. So the volume of the top piece is going to be 2 times 1 times 2, which is going to be 4. And the volume of the bottom piece is going to be 2 times 4 times 1, which is 8. And then we just have to add the collective volume, which is going to be 4 plus 8. So that means the total volume is going to be 12. And then one last thing is going to be the base method. So the base method is clever because we only have to find the area of the base times height. Remember, all prisms, the volume is base times height. So we can do this base, and then we just multiply by the height, which is 2. So the area of the base is going to be 4 times 1, which is going to be the area of this thing, plus 1 times 2. So we're going to split the T into two rectangles, and we're going to find that base, which is going to be 6. Then the height is 2. So then the total volume is 6 times 2, which is also 12. So the base method is a lot clever, a lot quicker in my opinion, but you can use both methods if you'd like. So that is indeed it for today. Chapter 10 and 11, simple stuff. It's going to be a good practice for tomorrow. Hopefully tomorrow we're going to get through everything quickly, and we're going to be going over the test. So tomorrow, here's the deal. So tomorrow we're going to start by review from chapter 1 all the way to chapter 11, and then no homework today. No homework. We're going to review chapter 1 to chapter 11, and then once we review from chapter 1 to chapter 11, we're going to do a small quiz or the final test, and everyone's going to hopefully do the test. Me and the TA will also do the test, and basically we're going to see how well you basically learn. So hopefully I'll see you guys tomorrow for the final day, which is going to be kind of sad, but kind of glad at the same time. But that's going to be for tomorrow. So hopefully I will see you guys tomorrow, and we're going to have our final day, and I will see you tomorrow. And just prepare, look over the slides if you like, the past homework, and then we'll go over that. So again, if you don't have any questions, you can feel free to leave, and that's it for today. So I can see you guys tomorrow. See you for the final day.